Hello my dear students, most welcome to our channel Shukla Maths Academy, Jabalpur. I am Professor G.P. Shukla, Director and Maths Faculty of Shukla Maths Academy, Jabalpur. Today in this video, we will discuss about the properties of Laplace transform. The Laplace transform chapter is very important chapter for the students of BSc second year and also engineering maths. So now let's restart. So now I am taking here two problems based on the first shifting property of Laplace transform. Now first problem is, see here, we have to find the Laplace transform of e raised to minus 2t into t square. So clearly the given function is of the form of multiple of exponential function. So we must use the first shifting property. So now take here ft is t square, right? Multiple of exponential function, we will take it ft t square, and after that we will find the Laplace transform of this ft t square, that is the factorial 2 upon s raised to n plus 1 means 2 plus 1, our n is 2, because the Laplace transform of t raised to n is factorial n upon s raised to n plus 1, so it becomes factorial 2 upon s raised to 3. And now say it is fs. And after that we will find the Laplace transform of e raised to minus 2t into t square with help of first shifting property by replacing s by s plus a in our fs. Because our a is negative, so in the fs we will replace s by s plus a, means s plus 2. So we get factorial 2 upon s plus 2 whole cube. That is our required Laplace transform of the function e raised to minus 2t into t square by using first shifting property. And now similarly we will find the Laplace transform of the function e raised to minus t into sin 2t. It is our second problem based on the first shifting property of the Laplace transform. So now first we will take the ft is sin 2t, that is the multiple function of e raised to minus t. We will take it sin 2t, and after that find the Laplace transform of this ft, that is Laplace of sin 2t is, we know that Laplace of sin at is a upon s square plus a square, right? So it becomes Laplace of sin 2t is 2 upon s square plus 2 square, and now say it is fs, and after that we must use the first shifting property. Then we get the Laplace transform of e raised to minus t into sin 2t by replacing s by s plus a, means s plus 1, because our a is here minus 1. So in our fs, replacing s by s plus 1, we get 2 upon s plus 1 whole square plus 2 square means 4. That is our required Laplace transform of the function e raised to minus t into sin 2t. So now there are so many more problems based on the first shifting property. So now dear students, you must try this property in other problems, and if you have any problem and doubt, then you can send me your problems in our comment box of this video. We will try to solve all your queries and doubts. Now next is second shifting property. It is very basic property. Now see that if we have to the value of Laplace of ft is fs, and we have another function gt. Gt is defined as f of t minus a when t is greater or equal to a, and it is 0 if t is less than a. And now we have to find the Laplace transform of this function gt. So Laplace of gt is given by e raised to minus as into fs, where fs is the Laplace of ft. And how we will find the Laplace of ft? If we left the value of a in the ft minus a, so we get ft, and we will find the Laplace of ft, then we get fs, and after that we must use the second shifting property to finding the Laplace of this gt. It becomes e raised to minus as into fs. Now I will take one example based on this problem. For example of the second shifting property is that we have to find the Laplace of ft, and ft is given by sin t minus a means 2, when t is greater or equal to 2, and it is 0 otherwise. So now see that first we will left the value of a, or we will find the function sin t, because Laplace of sin t is, we know that a means 1 upon s square plus 1 square means 1. Okay, that is say fs. Okay, and now by second shifting property, the Laplace transform of this ft, means this ft, it becomes e raised to minus as into fs, right? So e raised to minus a, our a is 2, so it is 2 into s as it is, and fs is 1 upon s square plus 1. So we get e raised to minus 2s upon s square plus 1. That is our required Laplace transform of the given function sin t minus 2 when t is greater or equal to 2 and it is 0 otherwise. So this property we must use when our function ft is given in this form. This form means that is the function ft minus a form when t is greater or equal to 2 means a and it is 0 otherwise. So we must use the second shifting property. Now next and third number property is change of scale property. That is very important property of Laplace transform. Now see here, if Laplace transform of ft is any function of t is fs, right? Then the Laplace transform of f of at, it becomes 1 upon a into f of s by a. I will explain this property by taking an example. Suppose we have to find Laplace transform of sin 3t, right, by using the change of scale property. So because the Laplace transform of sin t, we know that it is 1 upon, means a is 1, so it is 1 upon s square plus 1, right, that is say fs. And now by using this change of scale property, we must find the Laplace of sin 3t. Now see that, therefore Laplace of sin 3t, we are replacing t by 3t. So by using this property we get 1 by a. 1 by a means our a becomes 3, so it is 1 by 3 into f of s by, means also replacing s by a means s by 3 in fs. Our fs is here 1 upon s square plus 1, so replacing s by 3 whole square plus 1. On simplification, now LCM is here 9, so 9 becomes in the numerator and 1 upon 3 also, and it is s square plus 1, so it becomes 3 3 is 9, so it becomes here also 9, because LCM is 9, so it is 9, so that is 3 upon s square plus 3 square or 9. That is our required Laplace transform of sin 3t. And also by direct formula, Laplace of sin 3t is 3 upon s square plus 3 square means 9. So that is the application of change of scale property.